Let's investigate objects that go up and then come back down. First, we want to cover some basics. We need to know that gravity always acts downward. And we also need to remember that the acceleration due to gravity is 10 meters per second squared. That means that an object will gain or lose 10 meters per second every second. And gravity is the only thing that acts on objects as they go up and come back down. We're also going to talk about something called an apex. And the apex is the top of this up and down path. So just think for a second, if we have a ball in our hand and we throw that ball up, it's going to start at an initial velocity. Every second after that, gravity is going to act in a downward fashion, and that object is going to lose 10 meters per second every second. Eventually, it will reach its apex, where its velocity will equal 0. And then it'll start coming back down, where gravity is acting on it downwards, and it will be gaining 10 meters a second every second. So going up, as an object rises, it loses speed. Gravity is negative because it acts against the object to slow it down. At the apex, the speed of that object will equal 0. But the acceleration is still going to be 10 meters per second squared because gravity is still acting on that object. If the acceleration were 0 at the apex, the object would stop at that apex and not come back down. So let's consider coming back down. When an object comes down from its apex, it's going to gain speed as it falls. Now gravity is going to be positive because it helps to increase the object's speed. The object is basically in free fall from the apex until it stops at the bottom. The acceleration is 10 meters per second squared, but again, when an object is coming down, it'll be positive because every second it will increase its speed 10 meters per second. And it's also important for us to realize that the time it takes to go up to the apex will equal the time it takes to go back down to its starting point. So let's look at a problem where we're finding the time to the apex, or we want to find out how much time it takes to get to the top of that up-down movement. Our equation is T equals VI divided by G. And all of these variables should look familiar. We're going to divide the initial speed, that's our VI, by 10 meters per second squared, which is our acceleration due to gravity. And we need to remember that the time it takes to get up to the apex will be equal to the time it takes to get back down to the original starting point. To find the total time from beginning to end, we would take that time to the apex and multiply it by 2. So here's a question. How long will it take a ball to get to its apex if it is thrown upward at 10 meters per second? All right, so the first thing we'll do is we'll write down our variables. When the question says how long will it take, we're trying to solve for our time. The 10 meters per second is our initial velocity that our object starts upward at. So we've got 10.0 meters per second for our initial velocity. And we know that g is going to be our acceleration due to gravity, so 10 meters per second squared. We've got our equation. The time it takes to get to the apex equals our initial velocity divided by our acceleration due to gravity. So we'll plug in 10 meters per second for our initial velocity. We'll divide that by 10 meters per second squared. 10 divided by 10 is 1. So our time would equal 1.0 seconds. So if we were to throw a ball upward at an initial velocity of 10 meters per second, it would take 1 second for that ball to hit its apex. Now let's talk about how we would find the height of the apex. And to do that, we're going to take our dv, that's our vertical distance, equals 1/2 gt squared. Okay, use the time up or the time down as t. And if you know the total time from beginning to end, you can divide that by 2, and that'll give you the time to get to your apex. So let's look at another problem. Okay, here we've got how high is the apex of a rock that is thrown upwards if it reaches the apex in 3.50 seconds. All right, so this time we're trying to find out our vertical distance. Our time is given to us as 3.50 seconds. And we know that g, the acceleration due to gravity, is 10 meters per second squared. So to calculate how high our apex is, we're going to take our dv equals 1/2 at squared, or g, we'll change that. So we'll plug in our variables. We've got 1/2 times our acceleration due to gravity, 10 meters per second squared, times our time, which is 3.50 seconds, and we're going to square that value. So we'll take our time and square it, multiply it by 10, and divide it by 2. So we're going to get 1/2 times 10 meters per second squared times 12.3 seconds squared. Now we're going to multiply that by 10. We're going to divide it by 2, and we're going to get a vertical distance of 61.3 meters. That means if we were to throw a rock upward and it takes 3.50 seconds to reach its apex or its vertical distance will be 61.3 meters. If you need to go back and listen to this video again, to understand a little bit better about up and down problems, you can do that.